Bismillahirrahmanirrahim. Assalamu alaikum. Hi viewers, from this video we are going to start piping stress analysis series. It will consist of several parts and each part might have 2 or 3 videos. So stay with us if you want to learn and understand the complete concepts of pipe flexibility and stress analysis. This series will have basic concepts of forces, stress and strain, understanding of stress strain diagram, the relationship of stress and strain, how to calculate the stresses in piping systems, and understanding about the forces and moments and displacement at nozzles of different equipments. This series will have the actual tutorial of Caesar software, means explanation of Caesar software interface and different stages of performing formal stress analysis through Caesar software. This series will also provide you how to understand the Caesar software output results and how to do the nozzle evaluation, the flange leakage as per the actual scenarios. So let's start our journey of piping stress analysis. Let's start with different type of forces, either internal or external, acting on pipe during its entire design life. So the first one is the tensile forces. When two forces act uniaxial in opposite direction along the longitudinal axis of the pipe and try to elongate or increase the length of the pipe, these forces are called tensile forces. As you can see in this picture, tensile forces try to create the tension inside the pipe. Second type of forces, compressive forces. When the forces act in uniaxial direction facing each other along the longitudinal axis of the pipe and try to compress or reduce the length of the pipe, these forces are called compressive forces. As you can see in this picture, the compressive forces try to create compression inside the pipe. The third type of force is shear forces. When two forces acting perpendicular to the cross section or longitudinal axis of the pipe and try to shear off the pipe due to movement, these forces are called shear forces. As you can see in this picture, the shear forces try to create clockwise or anti-clockwise movement in the pipe. Torsional forces. As you can see here in this picture, when the applied forces try to twist the pipe, these forces are called torsional forces. Torsional forces create the torsion moment in a pipe, as you can see in this picture. The fifth one is bending forces. When a single force act at a single point, either between two spots or at a certain distance from one spot, but perpendicular to the pipe longitudinal axis, it will create bending moment in a pipe. So this is called the bending force that creates a bending moment in a pipe. Thermal forces. The forces generated in a pipe due to internal or external temperature of the pipe are called thermal forces. Due to thermal forces, pipe try to expand or contract in all direction. Occasional forces. The forces act on a pipe suddenly for a short duration, but occasionally are called the occasional forces, like for example wind forces, seismic forces, snowfall forces or snow forces, water hammer and relief wall thrust forces. These forces act occasionally on a pipe, but they have very severe impact on a pipe. Forces due to the pressure. This pressure could be internal pressure or external pressure. forces due to pressure creates three types of stresses inside the pipe. The forces generated due to the internal or external pressure on a pipe creates stresses in the pipe like hoop stress, radial stress, and axial stress. So, due to the internal pressure, these three types of stresses develop in a pipe: hoop stress, axial stress, and radial stress. We'll discuss in detail in further slides about each type of stresses developed in a pipe because of these external forces. Fatigue forces. The fatigue forces are cyclic in nature and they create fatigue stresses. So we'll discuss in detail about the fatigue stresses in further slides and type of fatigues and the reason of each fatigue in piping system. Let's discuss about the type of stresses produced in a piping system due to all those forces that we discussed earlier. First of all, the tensile stresses. The stresses produced in a pipe due to tensile forces are called tensile stresses. It is also called normal stresses as they generated normal to cross section of the pipe. Second one is compressive stresses. The stresses produced in a pipe due to compressive forces are called compressive stresses. These stresses try to create a buckle in a pipe. Third one is shear stress. The stresses produced in a pipe due to shear forces are called shear stresses. These stresses force one layer of the material to slide or deform in relation to adjacent layer in surface of the pipe. Fourth one is torsional stresses. The stresses produced in a pipe due to torsional forces are called torsional stresses. Torsional stresses try to produce torsional or twisting moment in a pipe. Bending stresses. The stresses produced in a pipe due to bending force is called bending stress. Bending stress is the distribution of internal forces and moment within a pipe cross section area as it undergoes deformation. Stresses will be tensile in nature at outer surface of the pipe or a beam and compressive in nature at inner surface of the pipe or a beam with respect to its neutral axis. Thermal stresses. The stresses produced in a pipe due to change in temperature of the pipe are called thermal stresses. So we'll discuss all these stresses in detail in our further slides. Hoop stresses or circumferential stresses. As we discussed earlier, due to internal pressure in a pipe, the three types of stresses are produced. The stresses produced in a pipe due to internal pressure of the pipe are hoop or circumferential stresses. Second is axial or longitudinal stresses. And third one is radial stresses. Hoop and radial stresses are taken care during wall thickness calculation of the pipe, while longitudinal stresses are considered during the formal stress analysis of the pipe as per ASME B31.3. As you can see over here, that sigma L should be less than sigma SH. It means the stresses in longitudinal direction during the calculation or formal stress analysis of the pipe should be less than the hot allowable stress as per B31.3. As you can see in this picture, the stresses developed along the axial direction of the pipe are called the longitudinal or axial stresses. The stresses developed along the length of the pipe in a wall, those are called the hoop stresses. And the radial stresses are developed in circumferential of the pipe are called the radial stresses. Occasional stresses. The stresses produced in a pipe due to occasional forces or loads are called occasional stresses. As per B31.3, section 302.3.6, the sigma occasional, which is a combination of sigma L plus sigma occasional, should be less than 1.33 times of heart allowable stress. So these are called the occasional stress, and during our formal stress analysis we will see how we can calculate the occasional stresses and how we can keep the occasional stresses within the allowable limit of the code. Fatigue stresses. The fatigue stresses produced in a pipe due to fatigue forces are called fatigue stresses. Fatigue in a pipe are of three types. Thermal fatigue, it is due to expansion and contraction in a pipe because of change in temperature. Second type of fatigue is called vibrational fatigue. It is due to vibration in a pipe due to some excitational force like slugging or vibration due to rotating equipments, etc. Third type of fatigue is called static fatigue. It is due to sustained load. When a pipe sustained a high load for a long time due to static fatigue, it fails after some times. As per ASME B31.3, section K304.8.3, pressure stress evaluation for fatigue analysis can be calculated through this equation. To understand the concept of stress and how the applied forces generate stresses in a pipe, let's take a simple example of a rod having uniaxial loading or tensile force, as you can see in this picture. Due to these applied forces on a bar, internal forces developed in a bar to resist the external forces. To keep the bar in equilibrium, the effect of internal forces must be equal to the effect of external forces, as you can see in this picture. That's why bar is in equilibrium and did not deform. In case the external force are more than the internal resistive forces, the bar shall be deformed as shown in the picture. These internal resistance forces are equally distributed across the entire cross section of the bar or a pipe. These equally distributed internal forces developed within a body is called the stresses. Hence, to calculate the stress, we can say that the internal forces per unit area is called the stress, and its unit is either Newton per meter square or pound per inch square. These internal forces are acting perpendicular to the surface of cross-section area of the bar or a pipe, and hence these forces are also called the normal stresses. In case of a pipe, stress distribution in bending is more complex. Stresses will be tensile in nature at the outer surface of the pipe cross-sectional area and compressive in nature at the inner surface of the pipe cross-section area with respect to neutral axis. To calculate the normal stress, we can simply divide the applied force by the cross-sectional area of the pipe or a bar as shown in the picture. In this case, the sigma is equal to the force per unit area. So the normal force and the normal stress can be easily calculated with this simple formula, which is the force which is acting on the cross section of the pipe divided by the cross sectional area of the pipe. I am leaving these two questions for you to think the answers of these questions, while you can find the answers in the next part of the video. Thank you.